lesson 25, reviewing de Moivre, since some of you are doing great with it, some of you are having a little bit of trouble, and then we'll go on to the advanced ones with de Moivres, meaning messier answers, as we work our way through that. So this next slide is all review. You already have all of this down in your notes. De Moivre simply says that if you are trying to raise a complex number to a fraction, if you have it in its polar form, then you can simply take the magnitude to that power times the cis of the power times the angle. But in order for this to work, it must be in polar form or cis form. It can't be in 5 minus 7i. It's got to be in cis form. Also, and this is also still reviewed, raising to a power gives one answer. So if we take it to the third power or the 17th power, we get one answer. But if we're taking roots, so we're taking it to the 1/2 power or the 1/5 power or the 1/12 power, we get more than one answer. And if it is 12th roots, we have 12 answers. If it's cubed roots, we have 3 answers. If it's 4th roots, we have 4 answers. And we figure out the first one, and then all we have to do to get the others is add to the angle. Whatever 360 divided by whichever root that is, that's how many degrees we're going to add on. And again, that is all review. That's already in your notes. So let's do a simple review of one that isn't an advanced one yet. -3 plus 3i cubed. Am I ready to use de Moivres? Seen a couple of heads shaking no. Julianne, why can't I use de Moivres yet? It's got to be in polar form before I can do that. So I must draw it, and I must pay attention to the plus and minus signs when I draw it. So -3, I'm going to go 3 to the left. +3i, I'm going to go up 3, which means I am in the second quadrant, which also means I better end up with an angle that's between 90 and 180 degrees. Now I can go through my formulas that r is the square root of the real part squared plus the imaginary part squared. And I can get that my reference angle is the inverse tangent of the imaginary part over the real part. But I don't have to on this one because I noticed, oh, I've got 2 3's. So this one is an isosceles triangle, which simply means that this angle and the other one have to both be 45 degrees. I've got a 45, 45, 90 triangle. And I could do 9 plus 9 is 18, so the hypotenuse is the square root of 18, which is 3 root 2. Or I could remember my reference triangle, and instead of 1's, I have 3's. That means instead of root 2, I have 3 root 2. So I'm looking at -3 plus 3i is 3 root 2 cis of something. My reference angle is 45. Do I put a 45 here? Emerson, what do I need? It needs to be 135 degrees. Is that my answer? I've done a lot of work already. Is that my answer? Sophia, why not? Okay, I haven't taken it to any sort of power yet. And I specifically wrote it that way. That's just what -3 plus 3i is. But this problem expects me to take it to the third power, which means I need to raise this to the third power, so I need to use de Moivres now. So I need 3 root 2 to the third power times the cis of 3 times 135 degrees, which means 3 root 2 times 3 root 2 times 3 root 2. 3 times 3 times 3 is 27. Root 2, root 2, root 2 is regular 2, root 2. So I have 54 root 2. Then I have cis of 405 degrees, but that's more than once around the unit circle. So 405 is equivalent to what, Nate?
45.
So 45 degrees. Is 45 degrees an angle where I know sine and cosine? So I'm going to substitute in and get an exact answer. I'm going to say 54 root 2. What is the cosine of 45 degrees going to be? Erica, what's cosine 45 degrees? Or root 2 over 2. And then I need plus 54 root 2 times the sine of 45 degrees times I. And Sophia L., what is the sine of 45 degrees? It is also root 2 over 2. Meaning, let's simplify. Root 2 is a regular 2. So that will cancel the 2 in the denominator, and I just have 54 plus. And the same thing again, root 2 is a regular 2, so that cancels this other 2. So 54 plus 54i, using de Moivre's to find that third root. Thumbs up, thumbs down, are we good with this? All right, another one still to review. 3 cubed roots of 8. Is 8 in cis form? No, so I need to get it in cis form. So I draw my picture and I want everybody point. Which way am I going to draw this one? Good, everybody's pointing straight to the right. Positive, real, nothing imaginary. So we're going there. So 8 is 8 cis. What is my angle? Shout it out. 0 degrees. Did this ask me just what is 8? It asked me for the cubed roots. So I need to take it to the 1/3, which means 8 to the 1/3, cis of 1/3 times 0, or 2 cis 0 degrees. I know cosine and sine of 0 degrees. Everybody, what's cosine 0? Louder. What is sine of 0? So that just gives me 2. Does that make sense? I asked you for cubed roots of 8 and we get 2. Well, does this much make sense? Is 2 a cubed root of 8? So we got what we expected from what we've known for years, but as Joe was reminding us, we need 2 more. How do I get my other 2? Emerson. Okay, so since we're doing cubed roots, we divide 360 by 3, so we need to add 120. And add 120, so I'm talking about 120 degrees and 240 degrees. I must label 2 cis of each of those. Do we know 120 and 240 degrees on our unit circle? So we need to plug in. If we are talking about the 120 degrees, we're up high in the second quadrant. Cosine is the x coordinate, sine is the y coordinate. What is the cosine of 120 going to be? So, say that again a little bit louder. The cosine's a half, negative a half in that second quadrant. And what is the sine? Root 3 over 2. So that means that we have negative 1 plus root 3 times I. Now let's do 240 degrees. That puts us down pretty low here in the third quadrant. So I need cosine and sine in that quadrant. So Reagan, can you help me out with cosine for 240? It is negative a half. Jeff, what about sine of 240? Negative root 3 over 2, and I want to see those substitutions, just like what I wrote down here. So negative 1 minus root 3 times that. So are we good with the review on DeMoss? Maya, thumbs up? Okay. So now let's do a messy one. Are we ready to use DeMoss on this? Kim, why not? It's not in cis form. It's not in polar form. So we're going to draw it. So 6, that's to the right. 4i, that's up. So I'm in the first quadrant. So I do want something that is between 0 and 90 degrees. So I need to say that r is the square root of 36 plus 16. So square root of 52, and I know I can simplify that as 2 root 13, but I'm going to hold off. Maybe I want to do that before I'm done. But for now, I'm just going to leave it root 52. Now I need your help with the calculators. My reference angle, and since I'm in the first quadrant, this will be the angle I actually use, needs to be the inverse tan of 4 over 6 or 2 over 3, whichever way you want to enter that on your calculators. So help me out. Everybody get that in on your calculators. Better end up with something in the first quadrant. Max, you have it already?
33.690.
Anybody else getting 33.690? Okay, I'm going to be doing fourth roots. Am I ready to start adding 90 degrees? Why am I not ready to start adding 90 degrees? That's the biggest mistake I see. Students get this far, and then they do 360 divided by 4 and start adding 90 degrees. Cal? I have to use DeMoss to get the first one. I haven't gotten the first one yet. So before I can start worrying about adding my 90 degrees, I need to say, oh yeah, I need the fourth root of this thing. So what I am going to need is the square root of 52, which I'm writing as 52 to the 1/2. That's square root to the 1/4, times the cis of 1/4 times 33.690 degrees. Now I'm trying to help you with the most efficient way to enter this on your calculator. The last thing on your calculator, I think, is 33.690 degrees, right? So I want you to go ahead right now, just do times a fourth or divided by 4, whichever way you prefer. And then you're going to let me know what you get before you start doing anything else on your calculator. Sophia, you have it already? Anybody else? 8.423 for the first one? Okay, so then I know I'm going to have cis of these things. 4 of these means I need to add 90s. So now you may do plus 90, plus 90, plus 90 if you want, or it's easy enough, you could do it mental math. That's what everybody has for your angles. Okay, now we don't really need to worry about the angle. It's okay if we do something else on the calculator. So now, since I wrote it this way, you can just do 52 to the 1/8 on your calculator. Instead of the square root of 52 to the 1/4, you can just enter 52 to the 1/8. Kenny, you have that already? Anybody else? 1.639? So then we write that down on each of these. And those are our four fourth roots. See what they mean about advanced? Messier. Let's do one last one, and that will be everything we need to cover today. So 5 fifth roots of negative 17 minus 14i. So I want you guys to get that into polar form for me. Draw your picture, figure out what that should be in polar form. Everybody looking for something in the third quadrant? So that means we better be getting something that's between 180 and 270. So can anybody tell me r is the square root of how much? What'd you get for 14 squared plus 17 squared, Julian? 485. Does that sound good to the rest of you? Can anybody tell me what you get for your acute reference angle? Just the inverse tan of 14 over 17? What'd you get, Erica? 39.472. Anybody else? Okay, that's just this little piece inside of here. What did you do to get your theta all the way around from the positive horizontal axis to that count?
180 plus the 30.
So 180 plus that row, which gave you what for the first one? Or for that part?
219.
So, is everybody coming up with this is the square root of 485 times the cis of 219.472 degrees? That's just negative 17 minus 14i, is that? Now we need to worry about the fifth root. So that means we need to take the square root of 485, or 485 to the 1/2, and then take that to the 1/5. And we need cis of a fifth times that 219.472 degrees. I think the last thing on your calculator was that 219 point whatever, right? So now take that times a fifth or divided by 5. And Reagan, do you have that already? Didn't need an equal sign in there, sorry about that. So 43.894 degrees is what we're taking cis of for the first one. Thumbs up, everybody getting that? How much do I need to add to get my other roots? How'd you get 72? Since we're doing fifth roots, we divide 360 by 5, so we need to add 72. So when you've got that 43.894, you can do plus 72, plus 72, plus 72 until you have all 5 of them. Or you can do it mental math. And check what I've got up here. Are these, did I get all of these angles the same as what you did? Make sure I added correctly. I didn't make any typos, just writing them down or anything. Okay, now I need you to do 485 to what power? To the 1/10th. And who's got that for me? So Joanne, what'd you get? Anybody else? 1.856? So we just copy that down on each of these. The magnitude stays the same for all of these. And put our box around. Also, I've double checked that you remembered the degree signs in every single one of those. And we've got the 5 roots. Any questions?